Hi and welcome to the On Maths prediction for the OCR Paper 3, which they call Paper 6, higher tier paper. Enjoy! Hi, I'm Chris Gilpin and welcome to this predicted paper. So we've looked at Paper 1 and Paper 2, taken away all of those topics and put them to one side, and we're just focused on the topics we have left. With those topics we've created the Paper 3 prediction. Now, I'm going to go through the entire prediction for one set of numbers, but if you go onto onmaths.com, I'm sure the link is appearing above me as we speak, then you can do the paper as many times as you want for absolutely for free, but it changes the numbers so that you're remembering methods and not answers. So it'd be a really great tool. Maybe do it once today and then another time tomorrow and just keep practicing it. You can also sign up for free and it saves your scores, and there's a whole load of other stuff on the website as well. Now, a caveat we always say with these papers is these are a revision tool. Obviously, please do other revision as well, but these are a great way of just checking to see whereabouts you're at with your revision. So I hope this helps. If you like this video, please click like. If you want to see more from us, please click subscribe. Enjoy. Okay, so this question's about an adult and two children. So we've got David Smith and two children. So there's one adult and two children. But the prices shown are not quite right because there's a discount. There's a fifth off adult price and 30% off the child price. So let's work out the adult price first. So a fifth off. Well, first of all, let's work out a fifth of £70. So to work out a fifth, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10, and so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 is 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want two children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80. So that's going to be £51.80. Okay, I'll move down a bit. And let's do the total. So the total is going to be the adult price, which is this one here, plus the two children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided, and you can just count the sides if you want, but you know, if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A, and that's absolutely fine. That'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha, well, Samantha's only got Christine left to play after we counted all the other matches. And Christine, well, Christine's matches have already been counted so far. So, we've got the 4 matches a liar's going to play, 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get 1 tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get 1 tissue. So I do 802 divided by 24, and I get 33.41 6 recurring. Okay, let's try the next one. So that's one done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much one tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out one tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42, because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87, because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question, so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it, and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. In this question, we're asked to draw the line y equals 2x plus 3. Now, there's no x squared or x cubed, so I know it's going to be a straight line graph. Now, there's multiple ways of doing this. I'm going to do it using a table, and then I'm going to show you a few other tricks of doing it much quicker or checking that you've got it right. The first number I'm going to start with is 0, and this, what I'm circling now, is going to be a coordinate to plot on our graph. So the top number, the 0, is the x, so this is when x equals 0. And what I'm going to do is I'm going to feed that into my equation. So when x equals 0, or y equals 2 times x, so 2 times 0 plus 3. 2 times 0 is just 0, so y equals 3. Now you don't need to do this working out for every single number, but I'm just doing it to show you how I'm getting to the y. So I'm going to try the next one without any working out. So we've got 1, and so 2 times 1 is 2, plus 3 is 5. Then the next coordinate, we've got x equals 2, so 2 times 2 is 4, plus 3 is 7. And the next one, we've got 3, so 2 times 3 is 6, plus 3 is 9. Okay, and I always go back to the negatives because I can kind of see a pattern with the positive numbers, so I can use that pattern to check that I'm doing this right. So 2 times minus 1, well, positive times a negative is a negative, so that's minus 2, and minus 2 plus 3, well, if I just use the number line, minus 2 plus 3, so 1, 2, 3 will be 1. And I can notice that they're going down in 2, so 9, 7, 5, 3, 1. So let's try the next one. 2 times negative 2 is minus 4 plus 3 is minus 1. Minus 3 times 2 is minus 6 plus 3 is minus 3. So those are my final two coordinates. The next step is to plot the coordinates on the graph. So my first coordinate is minus 3, minus 3. My next one's minus 2, minus 1. Then we've got minus 1, 1. Then we've got 0, 3. Then we've got 1, 5. 2, 7. And 3, 9. Now I want to join those up with a straight line. So let's do that now. And the last step is to label it. And sometimes you're asked to draw more than one line. So we should label it. There we go. Now, I can check that this is right because all of the numbers landed on the straight line. If I had one coordinate down here, I'd always check it. You're never going to have a straight line graph that goes up and then dips down, then goes back up again. Okay, so it's an easy way to check that you've got it right. Now, I said there was a quicker way of doing this. If you have a look at the graph, the equation, y equals 2x plus 3. This plus 3 tells us where it's going to hit the y-axis, so I can plot that one straight away. This 2 is a gradient, so if I go across 1, it tells us how far up it's going to go, and I just do that a few times to get 3 coordinates, and I can draw my straight line graph from that, and I don't need to put the table. But if the question asks you to fill out the table, obviously you need to fill out the table. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here, x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. You must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40, 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. For this question, the main thing we need to remember is the triangle. Now the triangle is like the speed, distance, time triangle, but obviously this has nothing to do with speed, distance, time. The formula says that pressure equals force over area. So as long as you've got force on the top, which is measured in newtons, then you're fine, because area and pressure can be the other way around. So if we're asked to find the pressure, so we cover up pressure on the triangle, we cover that up, and it says that it's force divided by area. And it says that the force is 2280 newtons, and the area is 38. So we get our calculator out, 2280 divided by 38, and I get the answer of 60. Now the units, because force is in newtons, and because area is either in meters squared or centimeters squared normally, then the units are newtons per centimeter squared. So it's 60 newtons per centimeter squared. Don't forget, it could be meters squared, newtons per meter squared, and that's absolutely fine for pressure. In this question, we're asked to find a unit ratio, which just means that we've got one of the parts or one of the sides of the ratio as 1. So we've got to make sure we understand the question. So there's 30 places and 112 people applying, and it's asking for the ratio of places to people applying. Now this is quite lucky, this question, because they're the same way around, but be careful, sometimes they'll ask for the ratio to be the other way around. So if we have places and applying, or applications, so we've got 30 places, ... and there's 112 people applying. Now it says it wants it in the form 1 to something, so we know we need to make this 1. And we do that by dividing both sides by 30. So 30 divided by 30 is 1, and I get my calculator, and 112 divided by 30 is going to be 3.73 recurring. So 3.73 recurring is 3.7333333. So if it says it wants it to 1 decimal place, it's a ratio of 1 to 3.7. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both a, you add the powers. Now if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. Term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's, and it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of -7 s to the power of 7. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimeters cubed, because every unit is in centimeters, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52 because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103. And therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side. 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got, so first of all, work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so Boxplot question. Now, it might be tempting to think that the information here is all you need to plot on the Boxplot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other two that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done, or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students, so I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. and so we're going halfway there. Now we can't really say 17.5, that doesn't make much sense. So on this question I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down because you've shown that it's 17.5, well you can't get half a student, so let's go for 17 or let's go for 18. Now this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population and then you capture a few more again, and then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, is this, it equals M. Now, M is the amount of things that you marked and then released. So on our example here, we marked 4. Times N. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here it's 2. So let's apply this to the question. Let's try and work out what M is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, or you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. Now this is a question about composite functions. And I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x. And the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So, all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question, just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the G to the 16. So we've done the F, and the F we did first because it's closest to the brackets. So whichever one's close to the brackets you do first. Okay, we've done the F. Now we need to do the G, and we just do exactly the same thing. So G of 16. We're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay. Perfect, right. The next one. This time it's important to notice that the F and G are the other way around. So it's G that we're going to be doing first and then F. Now the thing we're feeding in is X. Well, you can't feed in X as X. Well, you can. It's just going to remain as X. So let's focus on the G first. So we're going to do G of X first. And now G of X is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now F wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the FG brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2. So what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here, because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done, so we can cross that off. Okay, next one, we want to do the line x equals minus 1. Okay, so where does x equal minus 1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals minus 1. Okay, so where do we not want? Well, x is going to be greater than minus 1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, now the last one, I'm going to do the line y equals x plus 2. Now, there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC. And you could write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51. And the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, what is it, 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. Let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150. Is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you're doing this in the calculator paper, then please feel free to use a calculator. And we get 36 degrees. And again, it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorise the top and bottom, so put them into brackets, and then something will turn up. So let's factorise the top. So I know it's going to be x at the start. I need two numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorise the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need two numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3. This seems like quite a complicated question, but if you break it down into steps, it's much, much simpler. We need to find out, first of all, what the area scale factor is. Now, it's important that you realise that there's a linear scale factor, an area scale factor, and a volume scale factor. To work out the area scale factor, I'm going to get the 1731, which is the new size, and divide it by the old size, which is 2328. So I'm going to get my calculator, and 1731 divided by 2328. And when I do that, I get a horrible decimal. Now you can write it as the fraction that turns up, which is 577 over 776. We can write it as decimal, but keep it in your calculator, because the next step is to work out what the linear scale factor is. Now, there's no linear involved in this, but we need the linear one to then find out what the volume scale factor is. Now, to find a linear scale factor from an area scale factor, all you need to do is square root it. So I'm going to square root 577 over 776, or I've just kept it in my calculator. So what I'm going to do is press the square root button and then just answer, which is at the bottom of the calculator, bottom of the Casio calculators. Press equals, and it now gives me a decimal of 0.8622, blah blah blah. And when I do the little dashes at the bottom there, I'm showing the examiner that I'm going to keep it in my calculator. I'm not going to round it. Right, so we need to work out the volume scale factor. Now, to find the volume scale factor from the linear scale factor, you just cube it. So I'm going to show the examiner that I'm going to keep it in my calculator, but I'm going to cube it. So what I'm going to do is just press the X with a little square button, and then 3, or just press the X cubed button. Let's have a look, and that's going to be 0.6411, and again I'm going to keep it in my calculator, because the last step is to find out what the new grams is. Now, the reason we need the volume scale factor is grams is a three-dimensional thing, okay? So it's going to be involved in the volume. Yes, with volume normally it's centimeters cubed, but grams works the same way as centimeters cubed. So to work out the new weight, I'm just going to get 319, and I'm going to times it by that 0.641 blah 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 blah. So on my calculator I'm just going to times it by 319, and I get the answer of 204.5322 blah blah blah. It says it wants its two decimal places, so 204.53 is going to be my answer.
The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this, because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom, and frequency at the top. Now, it's a little bit misleading because actually this is proportional to the frequency density. So it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class widths, I can work out the frequency density. And the frequency density is the frequency according to the triangle divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2, so can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, so that would be perfect. So I can go up in ones on the 5 squares, so it would be 0.2 here, because they're 2 squares, 0.4, 0.6, 0.8, 1.0, or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high, and it's 0 to 10, so we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20, and it's 0.1, so it'd be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one, because it's only 1 square across. Let's try and get it as close as I can. So that's 1.2, but it's only 1 square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up 1 and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40, and we want it to go across here. So we're looking for an estimate for the amount that are in here. Well, if you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6, because the total frequency for that bar is 6, and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. With graphic transformations, anything that happens inside the brackets is going to be affecting the x coordinates. So what we're doing is we're taking away 2 inside the brackets. Now, when it's inside the brackets, it goes the opposite way around to what you think. You think take away 2, or I take away 2 from the x coordinate. Actually, you add 2 to the x coordinate. So the new point will be at 0.66, because I've added 2 to the x coordinate. So a minus moves the graph right, and a plus moves the graph left. Just try and remember it's the opposite way round to what you think. Anything outside the bracket will mainly affect the y, so that 2 there for question B will be affecting the y. It will basically stretch it out so that the y coordinate will double. The intercept will actually stay at the same points. So we've got the x coordinate's the same because that hasn't been transformed, but the new y coordinate is going to be 12 instead of 6. This question might just ask you to rationalise the denominator. It might ask this question the form that it's in, or it might ask you to show that that fraction is the same as another one, where you'll get marks for the working out. So to do this one, what rationalising means is basically what this one's here, because if you look, there's no root at the bottom there. What rationalising means is to get rid of the square root off the bottom of the fraction. Now I'm going to write this out again to make it a bit bigger. Now the only way we can do that with this question is if we times top and bottom by kind of the opposite of what it shows at the bottom. So instead of 11 plus root 5, I'm going to times it by 11 minus root 5. But if I do that to the bottom, to keep the fraction the same, I must do it to the top. So that creates a kind of quadratic surd. Okay, you do it the same way as you do quadratics, whichever method you want, first outside, inside, last, or double smiles and rainbows, or smiley face, or whatever you choose to do it. So I'm going to do the top first. So I'm going to do 5 times 11, which is 55. I'm going to do 5 times minus root 5, which is minus 5 root 5. I'm going to do 11 times root 5, which is 11 root 5. I'm just going to extend my line a little bit. And root 5 times minus root 5, well, positive times a negative is a negative, and any surd, when you times it by itself, it just becomes that number. So root 5 times root 5 is just 5. Okay, let's do the same with the bottom. So 11 times 11 is 121. We've got root 5 times 11, which is plus, it's 11 root 5. Then we've got minus root 5 times 11, which is minus 11 root 5. And then we've got positive root 5 times negative root 5, which is minus 5. Okay, now you might see what happens at the bottom. The whole purpose for doing this is you end up with the surds cancelling each other out. So let's simplify the top. 55 take away 5 is 50. And minus 5 root 5 plus 11 root 5 is going to be, well, if you think about it, you've got 11 of something and you're taking away 5 of it. Well, what you're left with? Well, you're left with 6 of it. So it's plus 6 root 5. Okay, now let's go through the bottom. Well, the two middle ones have cancelled each other out, so it's 121 take away 5, which is going to be 116. Okay, can I do anything else with this? Well, I don't think there's something that's in 56 and 116 apart from 2, so we can cancel all of that. We can halve all of those, so that becomes 25, that becomes 3, and that becomes 58. Now, the 3 doesn't go into 25, so we can't cancel it any further. So it's going to be 25 for A. B is the coefficient of the root, so that's going to be 3, and the bottom number is 58. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angled triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimeters and 5 centimeters, and all of them in centimeters, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras. So we're going to square them, add them, and then square root it. And we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61. And we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Oops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11, and we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places, so the answer I'm going to write is 54.62. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, oh, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try.
And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5. And that gets me 1.81712, blah, blah, blah. Okay, now I need to keep that answer. So what I'm going to do is I'm going to press the cube root button. Then I'm going to click inside the root. I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5. And we've got 1.9034, blah, blah, blah. Cube root button, answer plus 5. And we've got 1.9040, blah, blah, blah. Now, we're looking for 3 decimal places, so the numbers we're looking for being the same are these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple, because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x, because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x, because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher. Right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'm going to put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50.
Well, I hope you found that video useful. If you liked the video, please click like. If you really liked the video, please click subscribe. Please check out our website onmaths.com for some last minute revision. We've got all of the topics on there called Topic Busters. We've got quick multiple choice ones, which we have video explanations for instantly, called Minute Marks. And we've got a whole load of other stuff on the website. Thank you very much for watching.